Welcome to a flipped video lesson for Algebra 2. Today's topic is exponential growth. I'm going to do this segment in two sections. We're going to do one section on exponential growth and a separate video under exponential decay. I want to really explain the idea of growth and what happens to something when it's growing. Okay, so let's start with something very basic. If I suddenly won some awesome lotto that made my money double every single day, and it started with an amount of money, and I'm just going to say $50, and someone told me, you just won, and you're going to have every single day that goes by double the amount of money that you had from the day before. Well, that's exponential growth. So let's talk about what that means. If I start with $50, on the next day it's going to be 100 because it's doubled. If I double 100, it's going to turn to 200. Then it's going to go to 400 and 800, and I am going to be very wealthy very quickly. And this is definitely a dream of mine. But money isn't everything, right, guys? All right, so let's talk about this in terms of an exponential growth factor. So when you have an amount, that amount is a whole, and we're going to represent the whole using the number 1. And what am I doing to that amount? I'm adding 100% of that amount to that amount. So I'm taking the original 50 and I'm adding 100% of it. But what we have to do, I'm using my phone here. Okay, sorry. What we have to do is actually make this into a decimal, which if we do that, it's moving the decimal place twice from the right to the left, and that would become 1 plus 1, or 2. My growth factor would be 2. That becomes the base of the exponential function. So my exponential equation then would look like this. Y equals 50, representing my original amount, times 2 raised to the x power. So on day 1, 2 to the first power times 50 gives me the 100. So starting out on day 0, I start out with $50. So 0, 50. On day 1, 2 to the first times 50, $100. On day 2, x equals 2. 2 squared is 4. 50 times 4, $200. On day 3, 2 to the third power is 8. 8 times 50, I now have $400. And so on and so forth. And as you can see, if I put 4 here, I get $800. Okay. These coordinates, 0, 50, 1, 100, 2, 200, etc., they are the coordinates of an exponential growth function. So the factor, the growth factor, is 2, and the base 2 represents that I've doubled my money. Give me a second again as I fix this technical difficulty. There we go. Okay. All right, so let's talk about the y-intercept of this function. Where did I start? My money started at $50. Day 0, it was 50. The y-intercept of the function is where x equals 0. Remember, every time we hear y-intercept, we got to say x equals 0. Automatic. It's got to be like we know our name. We know that the y-intercept is x equals 0. So on day 0, we have 50. That means the y-intercept of the function starts at 50. Okay. So now what if I have an exponential function that does not have a coefficient in front and only has 1.52 as its base? Okay. So a base greater than 1 represents growth. So we know that this is growing. It's its original value plus a % more. So you take the 0.52, and we think of that as growing by 52%. So sometimes the question will say, how much or by what percent has it grown? And you know, 1.52, it would have grown by 52%. So if I see y equals 1.15 to the x, how much has that grown? Well, we know it's growing because it starts with a 1 point, so it's greater than 1, indicating growth, 15% growth. Okay, now what if I put a coefficient in front of it? So I say y equals 3,000 as the coefficient in front, and I 1.03 as my growth factor. I know it's growth because it's, again, b greater than 1. And then I look at this section to say that it is growing by 3% and start it off at 3,000. So whatever it is I'm talking about has a start of 3,000 and is growing by 3%. This again corresponds to my y-intercept of my function. Where x is 0, this whole thing will equal 1, and 1 times 3,000 would be 3,000. So y-intercept 3,000, growth percent 3%. Okay. Now what if I don't know my y-intercept and I don't have a function, but I'm giving a bunch of coordinates? And maybe I'm giving the coordinates in a table format. So on day 0, I'm at 5, 1, 15, 2, 45, 3, 135, and 4, 405. Okay, now I need to be able to write a function for this. So right off the bat, I want to look for, is there a y-intercept? Because the form of the exponential equation is going to take this form. Y equals a b to the x. A is my starting point, b is my growth factor, and x is my variable. Well, I have a bunch of x's and y's, so I can write an equation. Before I do that, I have to recognize that I also have a y-intercept. X is 0, that's my y-intercept. If x is 0 here, this term, b to the x, or b to the 0, would equal 1, and y would equal a. So my y-intercept is already known as the value 5. 5 equals a. So I can sub in right away a 5 in for my a. Now all I have to do is solve for b. But I could do that if I know other coordinates. Okay, so let's just say I know coordinate 1, 15 is the next one, so I'm going to sub it in. So y equals 15, a equals 5, I don't know b, but b to the first power is just b. So if that's just b, in order to solve for b, I would divide both sides by 5, and dividing both sides by 5 gives me 3, and 3 is the value of b. So my final function that I write is 5 multiplied by 3 to the x power. And now if I want to know how much did that grow by, that would have grown by 1 plus 200%. So this represents a 200% growth, because 200% growth as a decimal number is 2. And the original 1 plus 2 more gives me the growth factor of 3. So I automatically know that. Okay, now we're going to do one where we don't know the y-intercept. Because sometimes you're lucky and you get the y-intercept, and sometimes you're not, and you don't know what the y-intercept is. So let's take this next problem where I'm given points 1, 50, I'll do this one. Okay, 150 to 100 and 3, 200, and I'm given those 3 coordinates, and I'm told figure out the function and the growth percentage. So if I'm given this, I'm going to set up a system of exponential equations. Now, just like we did systems of linear equations and we solved them together through the elimination method, we're going to use a similar method but a different way of thinking about it. So here's what you do. We have the basic function y equals a b to the x. We have to solve for a, the starting point, and we have to solve for b, the base. Now, these numbers are kind of easy, so you could probably figure this one out, but let's just assume we don't know how to figure it out right now, and let's just go with the numbers. So I'm going to take any 2 points, and I'm going to use the bigger one first and set up an equation of this form with what I know. And I only know x and y, I don't know a and b. So y equals a times b to the 2nd power. Directly underneath this equation, I'm going to use this point. Y equals a times b to the 1st power. Well, you might be saying right now, well, that's b to the 1st power, so 50 equals a times b, and that's correct. But I'm not still sure what a is going to equal and what b is going to equal because there's a few factors of 50. So instead of kind of trying to figure it out, I'm going to take the top equation and divide it by the bottom equation. And you can do this with any 2 coordinate points. So if I do that, a divided by a will cancel. 100 divided by 50 is 2. And now I know my exponent rules that if I have the same base and I'm dividing, I subtract the exponents. So b squared divided by b to the 1st leaves me with b to the 1st, so 2 equals b. Okay, that means that I have a 100% growth rate, 2, because my number's doubling. I'm doubling each x value, it's doubling, 50 to 100 to 200. So it's like the problem I started off with my little money scenario where your math teacher got rich. Okay, so 2 equals b. Well, now I still need to find a. I need to find what it started at. So I'm going to go back to my original equation, y equals ab to the x. I'm going to choose one point, pick the easiest one. I'm going to pick the one with the smallest numbers. And I'm going to rewrite it. 50 equals, a is what I'm looking for, b is what I know, and it's raised to the 1st power, because x is 1. Well, that's just 2. And if I solve for a, I divide by 2 on both sides, and a is 25. So the function is y equals a, 25, my starting point, which is also my y-intercept, because that's what, when x equals 0, y will equal 25. B, growth rate, to the x power. Okay, that's it. We are done. Okay, so I hope you learned a little something about growth percentages and about exponential functions, how we write the function, how we solve for the starting point and the base, and how we identify automatically the y-intercept of the function. Part 2 will be decay, exponential decay functions. So stay tuned. In a few hours, I'll be posting that one. Okay, bye-bye.